pivots can't be 0. I don't accept 0 as a pivot. And I didn't get 0. So this matrix is great. It gave me 3 pivots. I didn't have to do anything special. I just followed the rules. And the pivots are 1, 2, and 5. By the way, just because I always anticipate stuff from a later day, if I wanted to know the determinant of this matrix, which I never do want to know, but I would just multiply the pivots. The determinant is 10. So even things like the determinant are here. Okay. Now, let me talk about failure for a moment, and then come back to success. How could this have failed? How could, by fail I mean fail to come up with 3 pivots? Tell me, I mean, there are a couple of points. I would have already been in trouble if this very first number here was 0. If it was a 0 there, suppose that had been a 0. There were no x's in that first equation. Does that mean I can't solve the problem? Does that mean I quit? No. What do? I switch rows. I exchange rows. So in case of a 0, I will not say 0 pivot. I will never be heard to utter those words, 0 pivot. But if there's a 0 in the pivot position, maybe I can say that, I would try to exchange for a lower equation and get a proper pivot up there. Okay, now, for example, this second pivot came out 2. Could it have come out 0? Actually, if I changed that 8 a little bit, I would have got, again, a little trouble. What should I change that 8 to so that I run into trouble? A 6. If that had been a 6, then this would have been 0, and I couldn't have used that as the pivot, but I could have exchanged again. In this case, because when can I get out of trouble? I can get out of trouble if there's a non-zero below this troublesome 0. And there is here, so I would be okay in this case. If this was a 6, I would survive by a row exchange. Now, of course, it might have happened that I couldn't do the row, that there was zeros below it, but here there wasn't. Now, I could also have got in trouble if this number 1 was a little different. See, that 1 became a 5, I guess, by the end. So can you see what number there would have got me trouble that I really couldn't get out of? Trouble that I couldn't get out of would mean if the pivot is, if 0 is in the pivot position and I've got no place to exchange. So there must be some number which if I had had here, it would have meant failure. -4, good. If it was a -4 here, if it happened to be a -4, I'll temporarily put it up here. If this had been a -4z, then I would have gone through the same steps. This would have been a -4. It still would have been a -4. But at the last minute, it would have become 0. And there wouldn't have been a third pivot. The matrix would have not been invertible. Well, of course, the inverse of a matrix is coming next week, but you've heard these words before. So that's how we identify failure. There's temporary failure when we can do a row exchange and get out of it, or there's complete failure when we get a 0 and there's nothing below that we can use. Okay. Let's stay with back to success now. In fact, I guess the next topic is back substitution. So what's back substitution? Well, now I better bring the right-hand side in. So what would MATLAB do? and what should we do? Let me bring in the right-hand side as an extra column. So there comes B. So it's 2, 12, 2. This is, I would call this the augmented matrix. Augment means you've tacked something on. I've tacked on this extra column. Because when I'm working with equations, I do the same thing to both sides. So at this step, I subtracted 2 of the first equation away from the second equation so that this augmented, I even brought some colored chalk, but I don't know if it shows up. So this is like the augmented. No, damn, circled the wrong thing. Okay, here is B. Okay, that's the extra column. Okay, so what happened to that extra column, the right-hand side of the equations, when I did the first step? So that was 3 of this away from this. So it took, the 2 stayed the same, but 3 2's got taken away from 12, leaving 6, and that 2 stayed the same. So this is how it's looking halfway along. And let me just carry to the end. The 2 and the 6 stay the same, but what do I have here? Oh, gosh. Help me out now. So now this is still like forward elimination. I got to this point, which I think is right. And now what did I do at this step? I multiplied that pivot by 2, or that whole equation by 2, and subtracted from that. So I think I take 2 sixths, which is 12, away from the 2. Do you think minus 10 is my final right-hand side? The right-hand side that goes with U, and let me call that once and forever the vector C. So C is what happens to B, and U is what happens to A. Okay, there you've seen elimination clean. Okay. Oh, what's back substitution? So what are my final equations then? Can I copy these equations? X plus 2y plus z equals 2 is still there. Then 2y minus 2z equals 6 is there. And 5z is minus 10. Okay. Those are the equations that these numbers are telling me about. Those are the equations u, x equals c. Okay, how do I solve them? What one do I solve for first? Z. I see immediately that the correct value of z is -2. And what do I do next? I go back upwards. I now know z here. So if z is -2, that's 4 there. Is that right? And so 2y plus the 4 is 6. Maybe y is 1. This is back substitution. We're doing it on the fly because it's so easy. And then x is, so x, 2y's is 2 minus 2. Maybe x is 2. So you see what back substitution is. It's the simple step solving the equations in reverse order because the system is triangular. Okay, good. So that's elimination and back substitution, and I kept the right-hand side along. Okay, now so that like is first piece of the lecture. What's the second piece? Matrices are going to get in. So I wrote stuff with x, y's, and z's in there. Then I really got the right shorthand, just writing the matrix entries. And now I want to write the operations that I did in matrices, right? I've carried the matrices along, but I haven't said the operation, those elimination steps, I now want to express as matrices.